Yeah, you might have noticed it's buy one, get one free on Joneses today. So we've got two of us. Matt and myself are going to talk a little bit about the evolution of BBC Online. Matt, do you want to introduce yourself?
Yeah, absolutely. Oh, good test of the microphone too. Fantastic. Hi, so yeah, I'm Matthew Jones. If you want to email me, I'm matthew.jones12, the one and only .12 at bbc.co.uk. I'm software engineer and manager for news and sport. I've been at the BBC for about 6.5 years now, and I joined as a senior engineer. And if you look hard enough on the website, you might still find some code that I've written, if you're lucky. And before the BBC, I also worked at Box UK, a digital agency just down the road as well. Craig?
Yeah, thanks, Matt. So I'm Craig. I've been at the BBC a bit longer. I think I hit 10 years in March next year. So I'm an architect now, lead architect, and prior to that, I've been pretty much every flavour of engineer in the BBC. Yeah, and we're here to talk a little bit about the evolution of the BBC online technical estate. Much like the term evolution in the title is very deliberately chosen. Much like Tom talked a little bit about with the DVLA about an hour ago, the BBC is quite an old, big, complicated organisation, and a lot of our tech has been around for a little while. So we're never really in a state where we can just kind of like rebuild it all. And so the way we kind of think about it is it's a constant evolution over time, a kind of slow evolution rather than kind of big bang short-term change. We've got a lot of stuff that's kind of inconsistent, and that's fine because they were all built at different times, and as long as they're all up to a certain level of confidence and security, etc., that's not a problem. So. A bit of context, I imagine most people here are familiar with the BBC. Matt and I both worked in news for a lot of our time here, and the BBC is the biggest digital news provider in the world. It has been for a while, and I put that up there not as like a brag or anything like that, but just to try to emphasize that we've got a lot of users, we're important to a lot of people, so I don't know if you can see the words on the deck, sorry about that, but we're important to a lot of people, and we never really have any quiet periods. We're a 24/7 service, we're used around the world. Today, pretty much everything that we do is on AWS. There's a little bit of GCP use, a little bit of Azure use for specific things. Generally, though, when we're talking about cloud, when we're talking about serverless, we're pretty much always talking about AWS. Yeah, you've seen these icons several times today. This is kind of like our serverless technology default set. This isn't an exhaustive list of what we use. Lambda being the preeminent one. Again, that's the one we talk about the most generally. We sort of think of ourselves as a serverless-first organization, but we're very much not entirely serverless, and we probably don't expect ever to be. But generally, we try to start at serverless and justify our way out of it, but it depends, right? There's different trade-offs with different problems. Right, big number, 10 billion. That's how many Lambda invocations we fired off last month to power the website and the news app, part of the website and part of the news app, which works out at about just shy of 4,000 a second if you flatten it out average. Obviously, it doesn't flatten out an average. It peaks and troughs quite significantly. And yeah, it's a big number, right? And people expect the BBC to always be available, especially BBC News. And so we pride ourselves on trying to keep our availability really high, 459s, et cetera, et cetera. But that's the kind of load we're looking at. Again, this is Lambda invocations. Most of the work to serve in that is done by AWS and by Lambda itself, right? We don't have to do an awful lot for this. To paint a super high-level picture, very basic, for a web request that comes in to the BBC estate, this is essentially what it looks like and how our split is between servers and serverless. Traffic management is mostly servers, we're still servers there. Web rendering is almost entirely serverless. Our business logic, which is a term we use for kind of like our data transformation stuff, that's mostly serverless. It's sort of getting towards being entirely. And then our kind of underlying platform and our content production, i.e. the tools that editorial staff use to upload videos or write news articles, that kind of stuff, those two are both kind of a mix. We're kind of on, again, an evolutionary path there. So that's all well and good, right? But that's today, and there's a lot there. But getting to where we are today was quite a long and interesting journey, at least I think so. It's a journey that's lasted probably most of a decade. So I just want to take you back in time to 2015, where I guess our journey into the cloud and the first start of our journey into serverless, where it began. So a few reminders about 2015 for the web engineers in particular in the crowd. This is when Node.js became a real thing. Node.js 4, like the first official production release came out. When React.js started to take off as kind of like a mainstream way to build UIs. Obviously, it's gone on leaps and bounds since then. And SPA, single-page applications, this is where they started to emerge, and isomorphic JavaScript became a thing. And just before 2015, in 2014 is when I believe Lambda was released. At least that's my understanding. Apparently Tom was writing Lambda functions in 2014, so it must be. But 2015 was also kind of like a milestone moment in the history of BBC Online technology. It's when we decided that we would move all of our online estate to the cloud. Prior to this, and still to a certain extent, the BBC owns lots of data centers, or maintains lots of data centers for various reasons. And prior to this, we had a managed ops model for engineering teams, but essentially based on a LAMP stack, Linux, Apache, MySQL, PHP, and Java, which I imagine a few of you will be familiar with. And this was kind of what you'd now consider probably quite an old school model where an engineering team would do some work, package it up, raise a ticket somewhere, and an ops team would come along on some date, grab it, deploy it to some number of servers somewhere, and then roll it back if it was wrong and come and shout at you. So, I mean, weirdly, it's almost like parallel with serverless there because you never actually see the servers or do anything with them. But yeah, we don't want to go back to that. So our move to cloud changed a number of things, right? We moved pretty hard sell to microservices at the time, polyglot engineering. So rather than just kind of everything web-based being PHP and everything API-based being Java, we branched out into a load of other stuff. As I mentioned, Node.js was becoming a big thing, and that would ramp up. Node.js is probably our most used language now, Matt, right? By quite a way. And DevOps arrived and an attempt at improving true CI/CD pipelines for our engineering team. So it was quite a significant change. And way back in 2015 is kind of like our first steps into serverless. Some pioneer teams or individuals, Tom, started working with Lambda a little bit. SQS and S3 was kind of where we really took off. We started to do a whole bunch of event-driven stuff in an attempt to seek efficiency with some of our workloads. Moving on to 2016. At this point, and we'd started this work, I guess, a year or so earlier, we kind of rolled out our own attempt at a serverless-like platform. And we took those kind of microservice principles and really went to town with them. And it kind of got a bit out of hand. Now, apologies for the grainy diagram, but because it's an old diagram and I couldn't resurrect the software that generated it. Every node on that graph, every circle on that graph is a single API, essentially. And this is the call chain for a single page on the BBC Sport website. We've taken decomposition a little bit too far, and it got a little bit out of hand. So what we learned from that, amongst other things, is that nanoservices is a very, very bad idea. Maintenance for that was problematic, to say the least. But one thing that was interesting about it is that we probably shouldn't be running our own serverless infrastructure at this point. Or serverless-like infrastructure at this time. But it got us thinking as an organization in like a serverless way, thinking about kind of pure functions, stateless, et cetera, et cetera. Although I guess we didn't necessarily know that at the time. Roll on a little bit, 2017. Lambda in particular and other serverless technologies are starting to gain some traction now. And late 2017, early 18, the weather website and app were rebuilt to make heavy use of AWS Lambda as kind of one of our first pioneer teams to do that in a really big production way. Bit of context for weather, it's quite a big, complicated beast, actually. At any time, there can be 1.2 million different weather forecasts every 5 minutes because of a bunch of reasons. And to deal with kind of the spiky nature of it, like when it gets snowy or when it's really hot, traffic goes through the roof, we moved the web rendering, or the majority of the core web rendering, to be fully serverless. Here's a fairly simplified diagram of how it works. I guess don't worry about the detail too much, but the left-hand side, where we're building like a web page or content for the user, that's servered. But the bit in the middle where we're grabbing the data from the external API, cutting it up into sensible formats and storing it, that's where Lambda came in, and it worked really quite well, much better than we anticipated. At this point, Lambda was still eyed with a little bit of skepticism as is this a thing that could genuinely really work? Rolling on 2019, we took that further. An example of this is when we moved our elections data pipeline to be entirely serverless, essentially. So here it's a similar kind of model. On the right-hand side, you've got some data coming in, and this is event-driven. When we get some results data for a state in a US election or for a county in the UK one, or another election around the world, that data is pushed to us, we're notified of it, so a Lambda function picks it up, chops it up in whatever way is required, stores that in a database, makes a notification, and some other things pick that data up via more Lambda functions, essentially. And then what we do is we stash all that data in its latest format in an S3 bucket and serve it out from there. One of the nice things about this is that elections are kind of weird in that they happen over like a 12-minute period, 12-hour period, or a few days in the US. And we want to be able to deal with really spiky, odd traffic at that time, and then they never get used ever again. So those Lambda functions can essentially get instantly archived, and they're very easy to get rid of. And because we've event-driven it all, the latest results are stored in an S3 bucket, which means we can always serve that data out, but we never need to worry about maintaining the infrastructure to generate them. Later that year is when we made a commitment towards what people would now, I guess, refer to as platform engineering. And we committed to a bunch of teams to develop a set of new development platforms, or a development platform for our user-facing experiences, so our websites and our apps and that kind of stuff. And so we built a new set of layered applications and essentially split into 3 layers. So routing and pre-flight, requests coming in, making sense of them, handling them, any caching at the top level. Optional web rendering, obviously you're building a web page, you need some web rendering. If you're building an app, you don't. And then data transformation for each of those purposes, and trying to unify our data transformation so that it's consistent across all platforms. The first one is, as I said at the start, is server heavy. The latter two are moving to be almost entirely serverless. So yeah, our web platform, all of our web rendering inside this platform is done inside a Lambda function or Lambda functions. It's server-side React rendering, progressive web app, the BBC website. Right now, today, it covers about 30% of what you'd call the BBC website, and it'll be about 70% a bit before this time next year. And this is kind of a bit of a blurry diagram about our data transformation pipeline. Platform. The bit in yellow is a series of Lambda functions that have been developed by a set of teams, and this is the call stack showing how we build a web page. It's calling a bunch of Lambda functions which are fetching and cutting up data from a series of upstreams. Yeah, so essentially it's a bit like a Lambda wrapper. It's a Lambda, but it provides some additional stuff out of the box, which I guess we'll get to in a bit. But people write modules are essentially code in folders as if they're individual Lambda functions, but with a standard library. And we give them, each of those is deployed as its own API. We get preview environments and things because they're just Lambda functions. And we get some caching and performance stuff out of the box. I won't go into a load of details about that. That's probably another talk. And that kind of gives us, brings us back to this. Like this is, again, now we're back to where we are today. So as kind of like a 10,000 foot or 10,000 meter view, that's probably quite interesting, but I imagine some people are wondering, like, I want some more detail. So I think Matt's going to take you through, in a bit more detail, some stuff about the BBC News article.
That's the plan. I'll do what I can. Yeah, so thanks, Craig. And this is one of our first ever news articles that was published online in 1997 using Craig's DeLorean. So the BBC's been telling stories online for over 25 years, and we felt that it was time that it deserved a story of its own. So this is a more recent news article from 2019, so just before the pandemic. If you're interested, Queen, Miley Cyrus, and Eminem were among the most streamed artists that year. So this was hosted on-premise in data centers across the UK, and it was a PHP monolith built on Zend Framework 1. It's kind of old school. I don't know if anyone's familiar with Zend Framework, and if you are, you probably don't want to be. Oh, we see some hands. Wow. So we had 60 million visitors during high-profile events to all of our article pages across the BBC. And we have around 1 million public service news articles that are published and live. But there's a real desire for experimentation, personalization, and creating new experiences for our audiences. And that was really difficult with the existing architecture at the time because it was entirely reliant on caching, which restricted our ability to experiment and personalize. And it was also a monolith, which made it really difficult for us to move quickly and break things. So it was time for a change. And the question was asked of us, how do you migrate 1 million news articles with 60 million users from on-premise to AWS? And how do you do that with zero downtime and during a pandemic? Which is quite a tough question to ask, really, of a team. So thanks for that one, Craig. Appreciate it. So in early 2020, we were given this problem to solve, working with Craig and many of the other teams across the BBC. And we're moving both from a monolith to a microservice and architecture, and from on-premise to cloud. And even though this book is 8 years old, at the time I guess it was slightly less old, it's probably the most relevant book for this problem. It's called Building Microservices by Sam Newman. If you haven't read it, I strongly recommend it. And this book talks about the idea of bounded contexts and starting to break down the anatomy of your page so that you can design microservices around it. So let's take a quick look at the article page and how we broke it down. At the top, we've got our news navigation, and this is multi-level navigation with primary and secondary nav. It's managed by editorial, so we have a data store that we retrieve our data from in order to understand how our navigation is configured. We create a Lambda in order to call the data store in order to get this data, perform surprisingly complex business logic on it, and then we are able to render that not just on news articles, but across the BBC. We then have our article content with 25 years worth of history of a schema that's continually evolved over time, with multiple content publishing platforms that editorial can use, one of which is the original one shown from 1997. So in order to deal with the content, again, we have a Lambda function, and we call the underlying content APIs and do a whole lot of business logic on it. And on the right-hand side of the page, we have our onward journeys. Again, they have their own data sources. So, for example, the top stories that we show are driven by audience metrics. Again, we use a Lambda to retrieve this data. Now, I know what you're probably thinking. This is all pretty simple so far, right? It's just a few Lambdas. But this, I think, is where it gets interesting. So by separating the page into multiple Lambdas, by using this news platform and the architecture that we have, and by taking advantage of serverless, we have more options. So earlier I talked about the idea of personalizing content for our users. Well, we now have the ability to do this. So if we want to show different content to users on the right-hand side of the page, we can combine our content with onward journeys, with metrics, with user data, and show different parts of the audience different experiences. And we're able to do that because of the way in which we've broken down the page. We can also client-side render, so we know that it's going to be slower to get all of this data for the user, so the platform gives us the option to client-side render. And I've already shown sort of several Lambdas and data sources here, and one thing that this also gives us the ability to do, which I think was mentioned earlier, was to architect for failure. So there is quite possibly a chance that one of our underlying data stores could fail, a Lambda could fail, we could start getting some unexpected errors, and we know that we can handle that with this infrastructure. So thinking back to the architecture that Craig shared and how this translates to news articles, our business logic is pretty much entirely serverless. And we're using our shared platform to enable us to retrieve data, to cache, to build in resilience with things like feature toggles and circuit breakers if there is an issue. And we're able then to utilize data from our various underlying content production systems. So the whole stack is still a mix of serverless and servers, but we're getting there. There's one thing missing, though, which is our web rendering. And that's a whole talk in itself, so I'm not going to go there. But as a summary, we use React and Storybook, and we have a Lambda that takes all of that data from all of those different data sources that we have, and effectively just calls react.render at the end of it. So that's it, job done. Not quite. So this approach worked really, really well, but it only got us so far because we still have other features on BBC News which require a different solution. And these include things like article comments, search, and local news. So the BBC has a commitment to showing local news which is aggregated from other news websites. We support around 50 regions of content across the UK. So in South East Wales, that would be things like Wales Online and the Penarth Times. We need to update these every 15 minutes so that they're updated and relevant for the user. And they feature across the website, so not just on articles pages, but also on other areas of the website, on our new and our old infrastructures and platforms. And previously, this was a Perl script running on a cron job. So how do we make a cron job serverless? And this was surprisingly simple. We realized that we could just use CloudWatch events. So we created a CloudWatch event for each news region, around about 50. Those events would trigger every 15 minutes, and they would invoke a single Lambda. but passing through a different location each time. That Lambda would then connect to our external data sources, do some business logic, and pop the content into S3 so it could be used across our infrastructure. And the great thing about this is even though it's a really simple, small example, it's also quite powerful, and it enabled us to migrate these pages into the new architecture. And it's also really cost effective. I think the last time I checked, I think it was about $1 for 1 million CloudWatch events. And even on the BBC budget, we can stretch to that. So we built all these things, and then it was time to roll it out. And the BBC normally loves breaking news. I can tell you for sure, I was very keen to literally not break the news. That would not have been a good day. So how did we roll this out? Well, it's a hugely collaborative effort across the entire of the BBC. It touches all parts of the architecture that Craig mentioned before. And we did have some constraints. Load testing was possible, but our test environment was not fully reflective of our live environment, and we had 25 years worth of evolving architecture to consider. Any load test that was planned in advance would require so much coordination across the business, and we'd have to test at thousands and thousands of RPS for it to be of any benefit. It also carried a little bit of risk, because if we misconfigured something, we could take down our live architecture. So we did instead utilize some chaos engineering, performing some experiments where we sort of, disable a cache or something like that and see what happened, and that was quite valuable. We then took a phased approach to rolling out. So we started by rolling out based on the URL of the content that we have, and we were lucky that editorial news desks kind of married up to our URLs. So in this case, it was an entertainment and arts URL. And this allowed us to roll out a relatively small percentage of traffic, about 5% each time, which then enabled us to understand how we were operating. Was this working? Was it viable? Was there anything else that we need to do in order to make this make progress? And this approach got us to around about 40% rolled out across articles across the BBC. But larger sections, which attracted a lot of traffic at the same time, were a bit more risky for us to move. And again, our focus here was to ensure that we had zero downtime. So what we did, which felt a little bit hacky, but I think it worked, is we took our asset IDs, which was like a 6-digit ID, 7-digit ID, and we took the last number of that. And we said, well, if we want to roll out to 10% of the traffic, let's just roll out asset IDs that end in 1. If we want to roll out 20% asset IDs that end in 1 and 2, you get where this is going, right? So it was creative, but it worked. And this also enabled us to, at runtime, set the configuration for how much we wanted to roll out. So we actually had effectively what was a feature toggle or a dial that allowed us to say, in real time, do you know what, this isn't working, let's bring it that down 10%, or do you know what, this is going really well, let's ramp it up. And what we found is it just worked. And I think that was probably to all of our surprise that we didn't experience too many issues. So we actually started rolling out faster than we anticipated. And it worked really, really well. Finally, just to touch on monitoring and observability, we use tools that are out of the box. We don't really have that many layers of abstraction or that many custom tools that we use. We use CloudWatch and X-Ray, and we also use Guard Duty just in case someone does steal our EastEnders audience data. Take a quick look at X-Ray. This was really helpful because it allowed us to trace the path of a request from the user throughout the entire architecture, both server and serverless. And we sampled this, I think, at around about 10% of requests, otherwise it would have got really costly. But even so, this was extremely helpful in the early days to diagnose and triage any issues that we had. It also allowed us to identify performance bottlenecks, and if there was a Lambda that was taking a little bit too long to execute, or if there was an instance that was quite slow, we would be able to figure that out quite easily. We also use CloudWatch for login, metrics, and alarms, and this is largely out of the box again, but we do have some custom parameters and custom queries that we use. And finally, we use CloudWatch to help us understand trends over time. So this diagram shows the number of requests to render article pages over the last years. And these numbers are kind of big. So in the last year, we've had nearly 5 billion requests to render an article page on the BBC. And with my really bad maths, I think that averages at around about 500 requests per second. Of those requests, we had about 80,000 requests that failed for one reason or another, so our error percentage is quite low. And this also doesn't include requests that may have been cached downstream or at CDN. And you can also see a pattern where we've had an increase in requests recently, and that's because we're rolling out across news, sport, children's, and weather as well. And you can also see how those requests end up resulting in more Lambda invocations. And we talked earlier about the article module, product navigation, things like that. Well, we can see it as being an increase in the number of invocations we have as well. I think currently we're running at around about 2 million Lambda invocations per hour for the main article body content. So what's the moral of our story? AWS has enabled us to move the BBC News from monolith to microservice at huge scale and with zero downtime. It's given us the ability to pick the right tool for the job, combining the benefits of a shared web rendering platform with custom server solutions where it makes sense, in the case of elections or in the case of the local news example. We utilize many AWS products like Lambda, CloudWatch, X-Ray, GuardDuty with minimal abstraction required. We're able to just kind of use them, which is great for our teams and great for if people move around onto different parts of the code base or different parts of the product. It's also enabled us to offer personalized experiences for our audiences at scale, with a high degree of performance and resilience. So I think it felt that our journey to serverless went relatively well, and I was kind of really hoping I'd be able to share like some really big horror story with you of how it was all on fire. And so far, obviously famous last words, it's fine. This is when someone tells me the BBC website's down, isn't it? So yeah, thank you for listening. I'll hand you back over to Craig. What's now, Craig? What's next?
Good question. All right, so kind of to wrap up. So what now? Surely serverless is working great. We should just make everything serverless, right? And I think it's certainly true that serverless has been a really great enabler and accelerant for lots of our teams. And by and large, I think the engineers really enjoy it. And I'm a big fan myself. But there's some such situations where we just still need servers, whether that be legacy applications that we just don't want to touch right now because they work fine, or where we need kind of specialist things that we don't have great kind of abstractions for at the minute. Generally speaking, although this is changing, we invoke our Lambdas via EC2 pools. There's a bunch of reasons for this, but we manage our kind of application permissions via server certificates. We have a bunch of custom metrics and some caching requirements. We generally try to, or almost always try to not call anything that might be slow from a serverless application. We tend to chain Lambdas, and what we don't want is a Lambda calling a Lambda 6 times and then onto a database that might take 35 seconds to reply because it's busy, because we're paying 6 times for that traffic. And if we're invoking 10 billion Lambdas and then a whole bunch of them are really, really slow, our cloud bill is going to go through the roof. So we tend to keep them as simple and as stateless as possible. Which is why sometimes we have the EC2 and they're doing that kind of heavy lifting for us. But that might change over time. Lambda kind of naturally leads to a more distributed design, which means we've got simple units, but when they add them all together, things can get kind of complicated. There are lots of pros and cons to distributed architectures, distributed engineering. Debugging can be a bit tricky at times. X-ray's been kind of critical in our ability to kind of keep our observability where we want it to be. And then continuous end-to-end testing monitoring is hard, but feels kind of always more important. And as has been mentioned before, it's a little bit harder to verify things locally. It can be a bit more tricky. The other thing, cost. So, I mean, I guess cost per CPU is more than serverless. It's a bit more expensive, but we're only paying for what we use. And generally, as I said, we keep our functions stateless, we keep them small, it keeps our cost right down. And total cost of ownership, TCO, is probably cheaper because engineer time tends to cost more than your cloud bills, well, usually anyway. And then I mentioned the dwell time. Chains of waiting Lambda functions can get kind of really expensive really quickly if you're not careful. So, yeah, in summary, we've sort of taken a serverless first approach, but we don't anticipate using it everywhere, just in a few key places or some key places. It's sped up development, made us more reliable and helped with scaling. It's led to a more distributed, stateless design, and it's now firmly a favored part of our toolkit, trying to stick to our mantra of always using the right tool for the job. And that's it. That's us.